has signed in for C-DEBI's inaugural webinar, Professional Development for our C-DEBI graduate students and postdocs. To introduce myself, I am Stephanie Schrader. I am the Education Director of C-DEBI. I am the one who sends out the plethora of emails, and any suggestions you have for various professional development, feel free to shoot me an email. Today we have with us a variety of experts in science communication. So we have Emily Yam, Dave Bader, and Jennifer Lentz. Jennifer Lentz from Aquarium of the Pacific, and we have Myrna Jacobson from USC. And with that, I'm going to let them take it away.
Thank you very much.
Thanks for the introduction, Stephanie. We appreciate it. I'm going to go ahead and make our PowerPoint look big here, bigger on the screen, and we'll go ahead and get started. So we did plan to have a reintroduction here so that you can actually see larger versions of us here, but we're really happy to be here today. We also wanted to let you know a few quick things about our workshop today. We are hoping that you back out there in cyberspace land at your desks and all will participate. We may ask you to jot down some ideas. If you want to grab some scrap paper right now or write this in your diary or your log journal for your lab or anything like that. We're going to ask you to jot down a couple of ideas. Also, at the end of this presentation, we will include our contact information, and we are happy to help you develop anything that you're developing with this communication topic. For instance, something that you workshop today, you can send it to us, we can have a look at it, and we'll let you know what we think.
Emily and I throw that out always, all the time, and the number of takers is always very low.
But I follow up every time.
You do, absolutely. So I swear we will follow up. It's part of our job at the Aquarium of the Pacific to help people be better science communicators, to help with any communication that you guys might have. So nothing's too small and nothing's too big. Well, no, that's not true. Some things might be too big. We'll let you know. But please, share back with us.
All right, so really quickly, once again, we'll go through and sort of introduce ourselves, a little roll call here. So today, your webinar here is going to be hosted by Myrna.
Okay, my name is Myrna Jacobson Myers, and I'm a biogeochemist coming out of the Bob Aller type laboratory. I study nutrient imbalances in sediment. I also make movies about fundamental principles of science, and I obviously, hopefully, teach and learn communicating science for myself and for the general public.
All right, thanks, Myrna. And then moving on, we have Jenny Lentz.
Hi, everyone. My name is Jenny Lentz. I just finished a PhD in oceanography and coastal sciences at Louisiana State University, which is what that picture is of. That's Mike the Tiger on my graduation day. Basically, I use GIS and spatial analysis to better understand coral diseases, and I'm really interested in using spatial analysis to study various environmental problems to help improve the current environment.
Thanks, Jenny. And then Dave.
Hello, I'm Dave Bader, Director of Education at the Aquarium of the Pacific, and I've worked at the Aquarium of the Pacific for 14 going on 15 years. So basically since the aquariums first opened, this was my job right out of college. So now I'm the director, but if you haven't been, please join us. It's a great place.
So you know Nemo, David?
I do, personally.
Yeah, I thought so.
And then my name is Emily Yam. I am the Science Interpretation Coordinator at the Aquarium of the Pacific. I haven't been there quite as long as Dave. I've been there almost 6 years. According to this picture, I yell at children and draw sharks. But in addition to doing that, I work a lot of professional development and translating current science into what our staff talk about on the floor of the aquarium. So that is my role there. And so we're really happy to be here with you guys. Once again, we do encourage your participation. Use the chat box. We are monitoring that. Also, you can always follow up with email, contact us. Anything that may help you communicate science better, we are interested in being involved. All right, so let's talk about why communication is important, which seems like a kind of simple thing, but it is very important. I think, in fact, the whole time I went to grad school, I never took any sort of course or anything that would prepare me to be a communicator of science. So it's one skill that I think is seriously lacking in our profession as early career scientists.
And I'll just throw out also that most of the people that we hire at the Aquarium Pacific are not expert communicators, but scientists. And they learn their practice, they learn their trade on the floor through trial and error. And at the Aquarium Pacific, we're working to try to create some professional learning so that the scientists that we hire can become better communicators. So this isn't something that is even endemic within the field of education in informal spaces. Extremely important and hard to find out there.
So, but that I think plays a bigger role in how scientists get their science out there and how that fits into the rest of the world. So we wanted to think about it in a different context, a bigger context for you guys.
Yeah, so what is our role as a scientist in public discourse? By public discourse, we mean general discussions with scientists, for instance. Use the word public discourse to also express to yourself in each one of these boxes an expansion of the idea. For instance, when we have the box scientist, the public discourse is with one's own self, okay? So you talk to yourself about your science, you talk to your colleagues about your science, and then you may extend that discussion to a more public role to colleagues outside of your science. And we would hope, as for a linear model, where one leads to the other. I tell a scientist, the scientist very accurately communicates to the general public. The general public is able to understand and expresses it to the government. And then from the government, we get accurate and appropriate laws and regulations.
And we know this is all true.
We know this is all true.
It's the only way that science affects all of the rest of society.
But in fact, what you know and what I know is that this is a big, nasty web. And we have many different examples of this nasty web. If you can think about smoking, disease control, global climate change. There are many different communication bugaboos that the scientists have suffered problems with. So one would want to know, what is the proper role for a scientist in the public arena? What do the boundaries look like? When do expert values and knowledge change and transfer into a political opinion? So these are many different things that are some quandaries that we have to suffer as scientists. And what we hope to give you here today is some useful tools to assist you here, working with yourself as a scientist and in all of the venues. So it's an extension, Emily.
And so, I think what we're really going to approach today is giving everybody who's participating today or might watch later some tools to help just be a better communicator. If you only communicate within the field of science, there are tools that we'll give you today that will help you be a better communicator just within that field of practice, just within the science field. If you happen to think that scientists should be great communicators outside the field of science, that's an open discussion. That one we'll have here, but these tools will help you there as well.
So science communication has been tricky in the past, and one example of that is just something of maybe not the best way to show science communication, and we're going to play a little clip here. I think it's sort of funny and sort of frustrating at the same point. Oh, sorry about that. It's okay, sorry about that, you guys. I'm just going to make this big really quick. This is an old-timey video, and we just want to show you a few minutes of this as an example of maybe not the best kind of science communication. So we'll start it right here. This video is actually called the Entabulator. So sit back and try to enjoy.
Reserve judgment. Maybe you think this is perfect.
Maybe you like it.
Sorry, we just realized you don't have audio. We're working on that.
You actually may be better off with no audio, though.
You can read lips,
I like
despite the pixelation.
Benjamin. I love your comment here. It's ineffective communication.
Well, we don't need to go too in-depth to that, but basically what happens in this very interesting and informative film clip is this gentleman uses words that I'm not even sure exist and describes his science using this model pictures, and it is not that different than what you just experienced anyway.
So I think the take-home of this, while meant to also amuse and entertain everyone, is to get us to think critically about how do we sound to other people when we talk about our what we do as scientists. If I talk about what I do as an informal scientist or an informal educator, maybe just that term right now. I just said I'm an informal educator. Does that mean I always wear jeans and t-shirts whenever I do education? Or
Beige.
beige. So these are the types of things that happen, and developing a better understanding of your own communication styles and how that communication is being received is what we're going to delve into.
And it can also help, if you're just talking to scientists, encourage collaborations between people in different disciplines. Because often if you're talking to people that you think should be on the same page with you, they may have absolutely no idea what you're talking about. But getting to bridge that gap can help really cross-discipline studies and help a lot.
Maybe Google Turbo and Tabulator a little bit later, and you can check it out.
All right, so we're going to take a moment and ask you guys to jot down a few answers to these questions here. So we call this a ponder this. So we want to know, who do you talk to about science? And we'll refer to these people as your audience, even though this is not a traditional audience in the sense like you're on TV or anything. But who do you talk to about science? What are some challenges in communicating science to these audiences? And think of an example when you have been a really effective communicator of science. And we just want you to take a few minutes, jot down maybe a bulleted list, or if you're a sentence writer, you can write sentences. These are not necessarily things you have to share with us unless you really want to share them, in which case we encourage you to type that into the chat box there. So go ahead and take a moment and think about it.
While you're doing that, Emily had mentioned before that we're actually going to ask you to engage with a few of these activities throughout. And while we can't tell if you're doing it or not through this forum, it really is something that will help you to be a better communicator. Writing these things down, as we say, is just a good way of creating new knowledge, creating new thoughts. It's something you can look back to a little bit later as well.
And as an aside note, I think it's really nice to be able to reflect critically and think critically and have that documented.
These are also common questions that are asked during job interviews. So for those of you nearing the end of your programs, these are things to have in mind that you might be asked during an interview. I was asked during my interview some of these questions, so just keep these in mind.
We'll give you guys a couple more seconds to finish jotting down a couple of notes there. We'll fill the room with silence.
I feel like singing the Jeopardy team.
Good today.
Yeah. Yes.
Okay,
This is the sound of the tabulator.
So for the rest of the audience, everybody watching can see this, but for Jenny and Emily and Stephanie, Benjamin Harrison has said, one funny example tends to be family, both in the sense of having plenty of opportunities to talk lay science to them, and also to do so in a safe environment. And I think that's a common thread that I've heard is people trying to talk to their own family about the research that they're doing as their example for the struggles they have with science communication.
It's the Thanksgiving dinner problem,
Right.
conundrum that all scientists have Just as a side note, my mom really thought I was studying medicine for many years just because I studied bacteria in the ocean. She's like, oh, you should apply for a job at NIH. And this is one of those things that Thanksgiving dinner conversation was difficult for us sometimes. So
my aunt thought I was in a large forum in a fancy dinner, and she announced as I walked in, this is my my niece, the scuba diver.
Yeah.
There was 15 years of education.
Yeah, I don't think my parents understood what I was studying until I invited them to my doctoral defense. And then they left and they said, I finally get it. And then half an hour later, they were trying to explain to someone, and I was just shaking my head thinking, well, you had that light bulb moment, but it's gone now.
So why don't we take a moment right now? Lauren is typing in that her friends always want to know if she's trying to discover the zombie plague. And it's quite possible that's what you are doing, even if you don't know it, right?
It's on the CDC's website.
So, but let's go to that second part of what are some of the challenges in communicating science to these audiences. We talked about all of us right now having these challenges, but Jenny, what do you think were the challenges that you had and your parents not really understanding?
Well, talking to family and friends was definitely a challenge, but another challenge that I particularly faced was the types of research I was doing for my field were new. Nobody else in my field were studying coral diseases the way I was approaching it. And so a huge challenge that I faced was whenever I would present my research at conferences to fellow people studying the same problems I was studying, was to not offend them and try and show them how we could do this together and improve both of our sciences, because people don't really like to hear new things. They feel comfortable with what they understand. And if you come at something from a different way, you have to be very careful not to say, my approach is better than yours, or this is all the problems with yours, because they'll immediately shut down and tune you off. So it was always a juggling act for me to try and not overemphasize the flaws in their research and try and show how my research complemented theirs and improved it.
So what I hear you saying in sort of a jargon-esque way is you need to know about the person's prior knowledge. And so in your field, since you were doing some remote sensing work and creating models, there was no prior knowledge in that. And so you were dealing with people's preconceptions of what they thought you were doing. And so you had to deal with what they had previously learned and then work from that framework.
And I'll just share with everybody that it's connecting right with what Brandon is saying on the chat, that everyone in the audience has preconceived ideas. Yeah. That's definitely a challenge.
And we will tackle that challenge in just a few slides, actually. So I think it's good to get the challenges out there. Are there any others that anybody would like to add?
Well, how about we go next to an example of when, you've been a really effective communicator of science.
I can give a funny example. I don't know that I was really communicating the point of my science so much as engaging the audience. When I was in college, I did a semester abroad at the School for Field Studies in the Caribbean, and I studied coral disease work there. And the way the program was set up, we were in a very remote place. There was no tourism. It was a fishing-dominated community. And at the end of the semester, all the students gave presentations to the local community on what they had studied there. And most of the presentations were on overfishing, endangered species. It was all the species that basically this population survived on. And they didn't want to hear it. They knew that they shouldn't be fishing conch. They knew they shouldn't be fishing lobster of a certain size. They didn't care because this is where their income came from. But I gave a talk on coral disease, and suddenly the audience just got engaged because it didn't threaten their way of life at all. And I started getting bizarre questions. For those of you who don't know anything about coral disease, you know a coral is a disease because weird things happen to the outside of them, like spots. Some of the diseases I studied were things like white spot disease, white band disease, and so you'd see color changes. And when I was describing this to the local community, I had fishermen raising their hands and saying, well, is it chicken pox? Did I give this to them? Do we just need to make them happy? Should I start bringing beer to the corals? And I would just say, no, please do not dump your beer on the corals. This won't help. They're stressed. And I got the most bizarre questions, half the questions. I would just look at my professors and say, I don't even know how to reply to this. But the whole audience lit up and they were excited about it. But part of it was that it wasn't threatening their way of life at all.
And I mean, I think it's very telling that you get these kind of questions that you were not expecting at all. And I think that's a big risk that we take every time we talk about our science and asking people what they know about. You just open up this whole spectrum.
And I'll throw out as well that while you got all of these off-the-wall questions, which you could go back and say, oh, that talk was not effective because the people didn't really connect exactly with what I'm saying. The idea that they were actually asking you questions.
They were very passionate about it. And
let you know that something that you said within your talk and the way that you said it was reaching them emotionally for sure and connected with them in a way. And I would challenge everyone paying attention here and listening in that was probably a very effective communication or an effective talk. And we'll talk a little bit later. It's always good to look for evidence in your audience for when things have gone well and when they've gone poorly. There's always evidence out there for letting you know one way or the other, and hopefully today we might be able to give you some ideas of how to make that connection.
There's a comment here that just came up, which was the discussion of little kids in airplanes. And I responded, the comment was, my fingers here, I believe I was saying something that it's a challenge to know what the audience knows, and you must provide that so they can follow your research and why that is and so on. So there's a lot of research on this, and it turns out that we as scientists enter a club. And in the first year of doing science, we may still be conversant in also the language of the human species. But after that, we are in our little tribes, doing our little war dances in our own self. And it is something to be aware of in our language of communication.
And I think we'll touch a little bit more on that as we continue. So what we want to do today is, now that we've talked about some of the challenges that we have with communicating science, and we've identified a few times when it seems to grab people and really engage with people, we're going to give you an opportunity to workshop something that you can actually use the next time you have a conversation with somebody about the science that you do. And we're going to call this the elevator talk. Now, I know a lot of people have probably done an elevator talk before, or maybe you've heard of it. But basically, the background behind it is imagine you're in an elevator with a very important person, and you have a captive audience for a short amount of time, and you want to tell them about what you do. So what do you say? And for now, we'll just set everything aside, and your challenge is to just write 5 sentences. So go ahead and take a few moments right now, jot down 5 sentences about your work, and you're in that elevator. What do you say? So if you want to take a few minutes there, we'll give you a few quiet moments, and then we'll have some of our scientists in the room share out. All right, while you guys are wrapping up there, we're going to have Jenny sort of share an example from her experience at first.
And this is going to be a rough elevator talk. So an elevator talk, if I hadn't gone through the training that you're about to receive. So this might be familiar to you because it might be similar to talks you've heard from fellow scientists. So this is my talk. My dissertation explored how geographic information systems, or GIS, and spatial statistics, specifically the techniques used to map, detect, and spatially analyze disease outbreaks, could be used to advance our understanding of coral reef health. Different types of spatial analysis, as well as different parameter settings within each of these analyses, can produce noticeably different results. Therefore, poor selection or improper use of a given technique will
would likely lead to inaccurate representations of the spatial distribution and false interpretations of the disease. For this reason, I performed a comprehensive review of all the major types of exploratory spatial data analysis, or ESDA, and applied these techniques to an artificial data set with known cluster locations in order to fine-tune each of these techniques and develop an analytical protocol that could then be used on actual coral data. I then applied the best techniques to a specific data set of coral disease outbreak and was able to better understand what was likely causing this outbreak. And it was the first time this had ever been done spatially with a coral disease outbreak. As you might have noticed, you may have tuned out. I used big words. I didn't try to include anybody or ask questions in there. But that's how many scientists would describe their research.
Here's something that I used very recently, yesterday. So David Bader, I loved your talk today on the Arctic blooms beneath the sea ice. I thought it was really fascinating. I thought it was quite good, yes. I was specifically interested in the part you spoke about your need for physiological markers for things like nutrient limitation. And I just wanted you to know that I work on this. I work on ecosystem, carbon, nitrogen, and phosphorus cycling. And I use enzymes which break down organics as indicators of physiological state. So I think I have an application that might be very useful for your research. And I hope that as we can talk about this further.
Yes, I think we could. That's the guy.
Okay, so that, I feel that was, I'm speaking to a fellow scientist.
Right.
I did some I was pretty high level, but did some defining of my terms so the person could follow what I was saying. And I kept it as short as I possibly could. And then we had an hour and a half conversation after.
So that actually is a good point, though. I think a lot of these, when you think about the elevator talk, it doesn't mean that this person is going to vanish on the next floor, although that could happen, and you have to expect and sort of be okay with that happening. But the elevator talk, in general, can also be the springboard for more discussion, more conversation between you and your audience, whoever it may be. So I think that's really well worth noting.
We're putting elevator talk in quotes here, mostly because I think you understand we don't expect you to be in an elevator. Although Emily has a story where she was actually in an elevator with the person that she wanted to do an elevator talk with.
Yeah, just you never know when you're going to have to do an elevator talk. I had to do an elevator talk during my defense, and I literally was trapped in that elevator with that human, the theoretical human, like 6 months later at a conference. So I actually used my elevator talk.
But we want to think of elevator talk a little bit more broadly than just this very short, very concise interaction between two people. Think of it more as that really engaging conversation that can last a very short period of time, a couple minutes, or it could be really engaged and last, like Myrna said, for the next hour and a half. When we presented elevator talk before, one of the comments back to us was that was the longest elevator ever, right, ever, or what happens if they continue to ask questions and
the door closes
and it lasts longer than a few minutes. Well, that's absolutely the best thing that could ever happen, right? This very important person that you want to convey your message to is engaged so much in your science that they're continuing to engage with you for a long time. It's not a bad thing, and I think everybody paying attention could, of course, understand that that's a good thing.
So we're going to take the 5 sentences that you hopefully just wrote down, and over the course of this workshop, we're going to fine-tune it so it actually becomes something you can really use. As we said before, and from my personal experience, you never know when you're going to have to give your elevator talk. And elevator talks are pretty important. Especially when you think about expanding that role. So what if you weren't talking to just a scientist? What if you were talking to other people? And so some of you may have written your elevator talk in terms of a scientist. Some of you may have written it in terms of the general audience. If you need to, go ahead and take a moment right now. or as we continue talking, go ahead and jot down a few notes about how you might change it. Because elevator talk can go for anybody. And like as I was saying, this is something we'll keep talking about through this workshop. The elevator talk has many, many different venues outside of elevators. Certainly you can talk to your lab mates, your colleagues, advisor, your committee, but even outside of that, you could be talking at public meetings, you could be asked to testify before Congress, you could be talking to a funder, certainly doing outreach, or interacting with the media, which is one of the more important but scary preparations you might have to make. For me, it's because I don't know what to do with my hands. But there's that issue. And then, of course, as we talked about earlier, communicating to your family, friends, and neighbors, having an elevator talk prepared is great.
And just to add to this, for those of you still in grad school or postdocs, conferences, as you know, almost always have happy hours. This is a great place to use your elevator talk. Has to be catchy so that they'll want to continue to eat and drink with you and continue. But this is how we network, and it really helps you long term. So you need to have these ready, and possibly even carry cards with your contact information that you just print at home, nothing fancy, so that when you've engaged somebody, you can immediately give them your contact info and have a contact later on that you can work with.
Okay. Do we have a question?
Keep going.
Okay. All right. So with all of this in mind, we're going to give you guys a couple of tools that will really help you hone your elevator talk as you continue. So we call this how to really engage people. And we're going to present to you a basic and a non-linear recipe. So this recipe can be made up of a lot of different things. You can certainly add different elements. This is the bare fundamentals of what you might need. And you don't necessarily put them in this order, and you don't always have a set amount. You have to just be really flexible and just understand that we will involve some sort of invitation with your guests or your audience, some sort of exploration with them, the eureka moment, that's what we call it, and then an application of that. This is how you can get people to really understand what you are talking about when you talk about your science. Okay, so we're going to break down a couple of these steps a little bit and invite you to then reanalyze what you've prepared in terms of those 5 sentences that you just jotted down earlier. So we are going to start with an invitation. That is how you get people. That is how you get your audience. And it'll need to be concise, interesting, and use appropriate language. So for example, if someone asks you like, oh, what do you do? You might be able to tell them something simple, right?
Yeah, like I teach piano.
Which is true. Well, not true for Dave.
Not true for me,
Right.
but
It could be a true statement, right? But that is not really some way to engage your audience to get you to talk to them more or get them to talk to you more, okay? So another way you might be able to say something like that is...
I give people the gift of music.
And that, I think, is a very compelling way. People are like, well, what do you mean by that? You know? So that's what we mean by the hook. What do you use to get people really interested to stand there for the next 30 seconds?
And thinking about this hook too, think about the statement that might get somebody to engage further with you. A short statement like I teach piano is forgettable, it's an end point, it finishes. I give people the gift of music, depending on the person, could end them, but it may bring up a question mark that leads to a further conversation.
We've actually had some experience with this with some scientists that we've worked with, and the sort of first pass at a hook for them was the beginning of their abstract, basically. So this is an example, just a pictorial example of it.
And this person studied, we'll just say they studied allele frequencies in pelagic open ocean fishes, such as, and I think they used the scientific name of the marlin that I have no idea what it is.
So that, not a very great hook for people because it's so technical. It's hard to get interested in that. But a really simple way to engage people is to really sort of poke at their sense of wonder about that. So you could totally change the way you said that.
And a different way could be, I study population and relationships between marlin, a very misunderstood open ocean fish. It's very important for fishermen and local economies.
Or I like what you said, Emily, you know, when we spoke about this slide.
I mean, if you're looking at DNA or something, you could easily just say, like, I want to figure out, as a scientist, how these fish are able to swim so fast and why that is. What inside their body lets them swim that fast.
Maybe instead of populations, it could have been relationships or something like that.
So that's an easy way to hook your audience, is just to make it interesting. Sometimes it even means changing the focus. So even if you're a lab-based, you never saw marlin the whole time you were in grad school, but you studied their DNA, you're allowed to talk about the marlin. It's okay. So you have to be okay with that.
And I think Emily's point about this too was that this very exciting, very charismatic, large open ocean fish was not part of this person's hook at all. It was the very detailed aspect of her research that was only interesting to her and the people within her lab, but not broadly interesting.
Do you guys have any examples that you wanted to give, or should we wait?
So I might revise my initial, more abstract-like hook to say, I am really passionate about the environment and specifically coral reefs, which, as you may or may not know, are declining worldwide. So my doctoral research focused on one type of coral that used to be the most common coral in the Caribbean and is now, as of 2006, the only coral on the endangered species list. It's been obliterated in the last 30 years mostly by a coral disease. It's the most studied coral disease, and to this day, nobody really knows what causes it. So I wanted to take a different approach and try and better understand this, as well as just environmental degradation in general.
So I think that's really catchy.
So I might say, I do biogeochemistry, so it's sort of tricky. So I might say something like, I'm sort of like an organic gardener specialist. I work on ocean sediments, and I look at it the same way someone might look at organic gardening and looking at the nature of their soils and sediments to see how the materials in the mud or in the soil change, the times, and the influences that they have on different things around them, plants and so on.
I think a commonality you might be seeing between all of these is thinking about the audience and what that audience might be broadly interested in, or something about it that might pose that question, like Myrna's comparison between organic gardening and marine soils or sediments.
And for mine, depending on where I'm giving the talk, if I did my PhD in Louisiana, I'd frequently say, because people that aren't used to corals, I'd say corals are extremely important because they mitigate hurricane damage. And specifically the coral I was studying, helps to keep the damage on land less severe. So we need to protect these corals.
So it's all about engaging with your audience. But that brings us to our next ingredient in the recipe here. So when we look at that, we want them to explore further. And I think the best way to do that is to encourage questions or to ask them questions. So you want to make sure that whatever you're talking about connects directly to them. And you have to go with what they go with. Sometimes it will surprise you the way they go with. So if we go back to the marlin example, for instance, you might be able to say, like, oh, I study marlin. It's a large open water pelagic fish.
Oh, I know Marlin from Marlin and Nemo from Finding Nemo. Marlin, that's what you said? You said clownfish?
Exactly. I mean, this is the type of thing that has happened before in the past. When you give someone an example, they go the other way. It is this total different thing. It's like, oh, that person knew what a marlin was, but knew it totally, like it was a cartoon, not a real thing. So that might give you information, force them to say, like, oh, actually, you're right. That is who marlin is. But there's actually a fish called a marlin, a whole group of fishes that are marlins that look like a swordfish. It has that big, long nose, and it has a big fin on the top. They're really fast, and they're really big, so people go fishing for them a lot. That's what I'm studying.
And connecting with that first bullet, provider relevant, specific, whatever, they connected with an ocean animal, a fish, and it's what they were excited about, so, go with it. I don't study clownfish. Marlin was a clownfish. Aren't they cool? I study a different kind of fish. That's also cool. They were excited. That's a great thing.
So really quickly, do you guys think you could add questions to what you were talking about that might help.
Sure, I have a conversation I could have with you. So remember, I just said I was an organic gardener, and I study nutrients in the, so I do something similar to organic gardening. And what I do is I study the balance of the different nutrients in the mud, in the sediment, in the ocean, the same way one would look at it in a garden. Do you know the difference between organic gardening and regular gardening?
I generally think of organic gardening as being the more environmentally friendly, healthy garden. If I'm going to have my own garden, I'd rather put organic things into it. But I don't really think much beyond usually the term organic's enough to lead me in that direction.
So you use the word organic, and organic means just what you thought, so I'm validating her. And so when you do organic gardening, you add organic molecules to help fortify the soil. But if you are doing inorganic gardening, you're just adding the nutrients flat, nitrogen, carbon, blah, blah. They do that sometimes in industrial gardening. So you can imagine that in the ocean, when you have organic gardening, sort of, these organics fall into the ocean mud, and in some way, those materials have to be recycled so that they can be utilized by the entire ocean community. So then from there, I would go on and talk about, shall I do this?
So I have a follow-up question. When I was living in Louisiana, we were constantly studying the dead zone, which is caused in large part by all the nitrogen coming down from these huge industrial farms, coming down the Mississippi, going into the ocean and creating this large dead zone. And I would go up to all these experts and professors after their talks and say, I'm a homeowner, I understand it's nitrogen causing the dead zone. What can I put in my yard to not be contributing to this problem? And I would just get these dead stares. But from the way you just described it, it sounds like if I had been using organic fertilizers and organic products, that would have lessened my already small impact on things like the dead zone.
Certainly when you use organic materials, it slows the rate of utilization. But there are definitely things you can do. I have an idea for you. It's called the donkey cart ecosystem. And by your farm, if you have a large cart that has an ecosystem that acts as a natural filter, where you run your water waste through that system, you can grow things on the waste, and that might work. But that's another conversation.
I'll turn it up a little bit. It's really cool. I mean, this is a natural conversation happening in this room, and it's connecting to everything that has to do with Myrna's research. And, you know, building off of that excitement is a way, but you have to get to that aha moment, the eureka, as we put it. You've got to bring them back. So you can go far afield down somebody's own interest, which may be the only place you ever get to go, but it might be worthwhile to think about how you bring this back to your own research as well. We're calling that the eureka moment.
So just in our example, once, for instance, the marlin example, you could go back and say, well, yeah, Nemo, and Marlin was Nemo's dad, but Marlin is an actual big fish and all that. And what I'm studying is looking at the individual, like the floor plans, sort of the architectural plan of the fish, and figuring out how that translates into how fast they are. And all those little secret plans are inside every one of their cells in DNA. Have you ever heard of DNA before? I mean, that's an easy way to sort of get people talking about it. And you can check back with people, but the bottom line is getting them to really understand what you are exactly doing. That's the eureka moment.
And the conversation that led in the exploration may be real helpful to building an understanding of what your science is, what you want to communicate with that person. But the important part about it is that they were engaged. And you can easily transfer from that. You can do a 90 or 180 degree turn from that to the point you want to make. And the point is that people really don't remember facts, but they remember experiences, and they remember engagements. And that's probably as far as you're going to get somebody in any just sort of haphazard conversation, which is what an elevator talk is. It's a moment in time. People will remember the feeling that they had during that talk. And that's the important part. If they associate you and a tidbit about your science with a positive feeling, they might call you back, they might email you, they might look it up further on their own. But that's the important meaty part, is that fun engagement part in the end.
And then just the fourth ingredient that we were going to talk about today is the application aspect. Sometimes you never get to that in an elevator talk, but that's really, the person is able to take it further. To say like, oh, this is what you do, like this other researcher, or this other thing that I've heard about once, or does this have to do with climate change, right? Like someone could have been talking to Jenny about coral diseases and say like, oh, you study that, well, does that have to do with that climate change thing? I mean, that's taking it further. That's how you know that you've really communicated what you needed to do. So I know we're running a little bit low on time because we talk a lot, but I just wanted to lay it out for you guys. These are the 4 ingredients we were talking about that really help you to engage with people. And of course, as I said before, it isn't going to be each one of these things in equal measure. It'll go all around, and you might jump between invitation and exploration for like 3.5 minutes before you even get to the eureka moment. But use all of that information that you're getting, all that engagement, use all of that to really connect with your audience.
Practice it,
Yeah.
and also use the concept of mystery. And you really need to sit down and think about it and practice it. And it will help you when you're in that elevator, quote unquote.
So that brings us to reflecting on that recipe. So those 4 ingredients there, and these are all really helpful. I think somewhat self-explanatory things to say, but what I think is most important is actually what Myrna said, is to really practice doing this.
So, and we'll just stop on this for just a second. How do you get better at communication? Practice, plan, think. How do you get better at anything? So science communication it's not necessarily a black box. It's not really a mystery. It's exactly the same as how you learned your science, how you got to be to the place you are. You did it through practice, through repetition, and through trying. One thing, though, is not to think that it's a mystery. There's evidence in your audience whether or not something good is happening. They're listening to you. Did they ask questions? How many? What was their body language like? Katie mentioned high schoolers a second ago. That it's really hard to get something out of high schoolers because they're too cool for school. And for them, it's also about knowing your audience. So thinking about the audience that you're presenting to is also important and part of this whole idea. High schoolers, too cool for school, so make sure it connects with something that's really fun, something that they're going to engage with, and not a standard lecture. If you know you have a real tough audience, then don't come at them with the same thing that hasn't worked before. You got to think of something different. It may work, it may not. That's where the practice part comes in.
As a side note, too, I think high schoolers are a tricky audience. For what it's worth, though, they probably learn more than they register. So always keep that in mind when you deal with them. Their body language is not an indicator of their learning.
And realize also that, and I typed this out in the chat, the aha moment doesn't always happen in front of you. It more than often will not happen in front of you. It'll happen down the road. So don't lose faith if you don't feel like you've gotten through to somebody. If you've gotten those good questions or furrowed brows, people asking, people being really upset with what you've said, even being upset with what you said, that's possibly a very good thing. It means they were wrestling with the idea.
And we'll talk about why that is. We call that, there's a name for that in education, but when people get upset but not in a passionate, politically identifying way, but they're just puzzled by what you said.
I'm sure everybody's experienced this before.
So there is actually an entire field of research devoted to informing all of these things that we've been telling you about, this recipe that we've told you about. It comes from formal education, but also expands into informal education, which is the field that we come from aquariums, museums, zoos, and science centers. We're going to share with you a little bit about that so that you know that this is actually rooted in the social science. Learners actually construct their own knowledge, and they get those experiences through lots of different things. Doing things, engaging with things, manipulating objects, and talking to people. That's why this has been over time, if you think about the best learning experiences you've had in any venue, it's probably involved one of these three things. And if you look at the dates on these, relatively recent, in the recent history of things, we're really only just now starting to think about how people learn.
And worth pointing out, the Vygotsky, that conversations are important, because I think that's probably one of the things that most often we'll miss, that conversations are important for learning. And that's not how we learn in graduate school or in college. We learn through somebody talking at us, not with us.
But we do know that in research groups, we make the biggest leaps when we are sitting in a research group reflecting back and forth. And let me just insert that all of this information we're presenting to you now, in addition to you learning about it as we speak, you can use these PowerPoints and these concepts expanded in your NSF outreach to cultural groups and so on.
So keeping that in mind, the learners connecting information with what they already know, it builds on prior knowledge. And Myrna talked about this a little bit earlier. I like to think about this from the kid point of view, like when we think about kid logic. So I'll just share a really quick anecdote that I've heard about before. There's this little girl, and she and her grandmother, before the days of 9/11, used to go and watch her dad leave for business trips. And they would sit in the airport, he would board the plane, and then get on the plane and take off, and they'd wave at the plane. And this is sort of a ritual they did. And then it finally came time for this little girl to go on a flight herself. And so she and her dad got on a plane, she got buckled in, and then they started to take off, they taxied, and they actually took off from the runway. And the little girl turns to her dad and says, "This is the part where we get really small." And her dad's like, "What?" She's like, "This is the part where we get tiny, we get small." And when you think about it, it's like, of course that makes sense, because her understanding of planes taking off was she would sit there and watch until her dad's plane got really, really tiny and it was gone. And so it made perfect sense for her to make that connection. And when you think about kid logic, it actually explains a lot of people logic. So a lot of times we go and we're like, I can't understand that person. But if you really break it down, you can really think about why people think the way they do from those experiences. And so this actually has a term, if you look at it and or see it in education or in your NSF or impacts things, a lot of times they'll say you have to scaffold your knowledge, you have to build that up. And that basically means that given any set of tools, people will build their understanding over time, and they keep adding and building onto whatever structure it is that they've got inside of their brain. And that's why we said sometimes you have to unlearn things, or when people are puzzled, they have to sometimes knock parts of their knowledge down.
And the idea about this is people build an understanding of the world around them, even if they have no business doing so. This little girl who the plane was getting smaller. So you have to understand people's preconceptions. And how do you do that? By asking questions, by engaging with them. So that middle part of exploration was a way of finding out what somebody knows.
So, these are just our tips for when you are actually talking to people. How does this affect you? Well, you really do need to connect to what they know. And sometimes you got to do it a couple of times. And you have to be flexible. You have to be willing to get those totally strange questions and take the time to understand where they're coming from, or else you won't have meaningful meaning-making on their part. So we're going to ask you really quickly, I know we're running a little bit short on time, but just to have a quick look at what you wrote down before, and see if there's any opportunities, or if you can think of questions that people might ask you, or questions you might be able to ask them to engage them further, to figure out if there's ways for them to understand your research better.
And I think we'll run just a few more minutes over. And the next slides that we have will be some specific tools that you can insert into your elevator talks or your practice. But again, the point of this too is you have something written down right now. We've talked about practicing. We've talked about making sure you engage people with questions, that your hook is something that's interesting, that connects broadly with people, and maybe a hook that connects to causing them to think a little bit, so they have to ask you a question, not in a weird kind of I hate you way, but a, ooh, isn't that interesting kind of way. Those are different strategies that you can use to really engage somebody. And why don't we, since they'll have this written in front of them, why don't we continue to some of those tools?
Okay. So here are the tools we would recommend to further clarify the science now that you've gotten a chance to figure out what people know and really connect to them about it. And we're going to go over them really briefly, but I'll list them here. We're going to talk about the language you use, models that you may use, building those stories through causal chains, social math analogies, and I know that we wrote avoid jargon, even though we've listed an entire list of jargon here, and I will take a moment to recognize that, but we have to call them something. So let's see, what do we mean by this when we mean these communication tools? The first thing is, of course, to recognize, as we mentioned before, that science has its own language. Science is its own culture. I mean, there's values associated with science, there's norms, there's rituals that we have in terms of like getting peer reviewed and all of these things. These are rituals that are only known in science that people outside don't know. And so if you think about it, terms that you use in science may mean something completely different in the public. So we've also included a list of choices here. This comes from a paper that's been published a few times, or rather, it's a chart that's been published a few times, but it stems from work by Richard Somerville, who's a professor at Scripps. So just really quickly, is there one that resonates particularly with either of you guys?
For me, words like theory and uncertainty really hit home, especially when it comes to climate change, because climate change deniers tend to say, well, that's just a theory, or but scientists are still uncertain. But that's how science works. We try to work towards limiting the uncertainty, but there's always going to be uncertainty. So it's trying to find new words that help not make it seem like it's weak.
Yeah, uncertainty in science just means something totally different in the real world where they're like, well, you just don't know, you know? And so being able to reframe that in a different way is really important. So I really like this particular list. I think it's an interesting one to think about. Another tool that we use are what we call simplifying models. For example, we've known for many, many years, we call it the greenhouse effect. There's this model that we use. We say, oh, it's like a greenhouse. It heats up. Except that even social scientists have gone out and analyzed this, and they've come to terms with the fact that people don't know what a greenhouse is, or they don't connect with that. They don't know how they work. Or if they know it's a greenhouse, like you grow tomatoes in a greenhouse, maybe a greenhouse is something good because stuff grows in it. So we actually use a new model for that description. Dave, if you want to take a second to talk about that.
Yeah, instead of a greenhouse, which people think are good things that help stuff grow, may not really understand the mechanism of climate change using that, you could use a carbon dioxide blanket. And people understand that blankets are something you put on when you need to get warm. So people can understand that carbon dioxide might be warming the planet like a blanket warms your body. And you know, taking that a little bit further, you might say that it's like a wool blanket versus a cotton blanket. You know, right now we have, you know, in the 1800s we had a cotton blanket on, and now we have a wool blanket on. You know, they might understand that there's a difference in the quality of the blanket over the planet. So using that analogy, but also understanding that every model and analogy has a downside. They're never 100% accurate, and I think you can use them as long as you use them wisely, and you let, if there's a problem with the model, you air that. So for this, for a blanket, you could also say, hey, it's like a really thick blanket. But that might make people think that the atmosphere is actually getting thicker with carbon dioxide, which it's not. And that wouldn't be something we want to do as scientists, to create that preconception or misconception. So, you know, airing that. The atmosphere is not getting thicker like a thick, warm blanket, but it's acting like a blanket. Okay, I get it. It's not getting thicker, but it's like a blanket. It makes us warm.
Another tool that you guys can use are causal chains. That's basically one thing leads to another, leads to another, leads to another. And this is actually something that really helps people understand things. For this particular example, given our time, I'll talk about food webs because people really understand food webs. For example, when you take out the sea otters, you don't get predation on the sea urchins anymore. the urchins take off, and then they eat all the holdfast for the kelp, and then the kelp actually disintegrate. They actually unattach because they've been eaten at the bottoms, and that becomes a whole ecosystem that gets dislodged. So that is the kind of causal chain that people get. One thing leads to another, leads to another, leads to another. And that's a really effective tool that you can use. Sometimes you can even just use a really simple chain in order to do that. Okay. Social math is another example of a tool that we use frequently, especially when you use numbers and sizes.
And this is just an easy way of connecting people. I think it's pretty easy. Blue whales are 88 feet long. What is 88 feet? Who knows? They're as big as 2 school buses. I can visualize 2 school buses. I like Myrna's example from recent news. There were 60 houses that got damaged during the fertilizer plant explosion. 60 houses, that's like, how many would you say? 6
3
blocks?
square blocks. I had to visualize how many blocks there were. But this social math, you can also use it explaining things to yourself. I have to explain to myself P31 NMR when we finish this conversation so that I can understand what my results look like. And I'm going to use social math to explain it to myself.
And that last picture, just so you know, is sea level rise, because a lot of people struggle with even understanding the impact of something. So if you have a projected sea level rise of 6 feet, that's like saying almost the whole first floor of your house is underwater.
So you can tell that we've thought about these ideas in terms of trying to help people have a better understanding of climate science. And we have a few others that we're going to skip through, but you'll be able to go back to them if you find yourself finding this useful. There's a couple other analogies that you can use for communicating the difference between weather and climate, and then also, that the Earth is maybe sick, and the CO2 concentration is analogous to a healthy body temperature. What's the healthy CO2 level?
Versus having a fever, for example.
Right. Well, you can go back to those. I think we've got the idea.
So just to wrap it up here, we do have a list of tools here if you want to take a moment just to finish jotting them down. And I do encourage you to think critically about the work that you do and see if you can apply one of these tools to some aspect of what you do, just to make it so that people understand, what you do, the methods that you use, or why you're doing it.
I think the last one, why does it matter to me, my research? Why does it, because I need to get my PhD. No, it's not why it matters. Maybe that is why it matters to you. Why does it matter to them? Those are good questions to ask yourself and be able to answer concisely. And then all of this is going to get uploaded, so you'll be able to link to all of this, including, I think, the most important thing, which is our contact information. So
I realize that I have a typo on here, but we do teach a course that is sort of rooted in the fundamentals of teaching and learning. It's actually the fall of 2013, which is this year and not next year. It's called Communicating Ocean Sciences to Informal Audiences. We teach that here at USC, but it's also taught by our colleagues at a network of universities all around the country. So we do encourage you, or if you'd like to find out more information about a COSIA course going near you, you can certainly send one of us an email and we can get you in touch with regional people who might be doing that work. And so we encourage that kind of participation if you want to learn even more about it, more communication skills. Otherwise, if you want to workshop the things that you've done today or things that you are working on coming up, send us an email. We have all of our emails listed right here, and we are happy to help you figure out the best way to communicate with whoever your audience is.
So we will sign up. We can continue, I think, probably chatting for anybody who wants to stick on and chat a little bit. But thank you guys for participating with us.
Registration for this course is happening right now.
So if you're at USC, join us.
Join us, yeah.
But this year,
course.
Yeah. This year, not next year.
If you're not, it's likely or possible that a university near you teaches COSIA, because it's all over the country.
So I want to thank you all for joining us, and hope that you have a wonderful day.
Yes, and thanks everyone for the first inaugural